Hey guys, welcome to section 4, chapter 6 of the geometry program. And in this section, we're going to learn some unique theorems about particular parallelograms. So like all of the sections in this chapter, we got to start with some theorems. So the first theorem is going to say that each diagonal of a rhombus bisects two angles of the rhombus. So if we're just going to review, a rhombus is like a square tilted on its side. All of the sides are congruent. And this theorem tells us that if we draw the diagonal, that the angle with which the diagonal goes through is going to cut it into two equal parts, meaning this guy is congruent to this guy, and this angle is congruent to that angle, right? So to review, bisects means to cut in half, right? So it splits those angles in half. Okay. The next one, the diagonals of a rhombus are perpendicular. So you're going to get good at drawing your tilted squares here. And if you do a half decent job, then you're going to see a right angle form in there between the diagonals. So the diagonals of a rhombus are perpendicular, meaning they all have 90 degrees. All right. All right, keep moving on. Next one, the diagonals of a rectangle are congruent. And that kind of makes sense if you think about it. Because a diagonal there is going to split it in half, and a diagonal there is going to split it in half. And actually, we could prove that this triangle is congruent to this triangle. So those two diagonals are congruent. So that's unique about a rectangle. I did not go back and put the converse of each of these, but the converse is true. So if a diagonal bisects two angles of a parallelogram, then the shape is a rhombus. If the diagonals form a perpendicular, then the shape is a rhombus. And if the diagonals are congruent, then the shape is a rectangle. So the converse of these theorems are true as well. So make a note of that. I don't think that you have any of those in your homework tonight, but it's good to just know. All right, a couple of examples for you, and we're going to wrap this up because it's super easy. So assume that all of these shapes that we give you are rhombuses. And what we learned was that a diagonal splits the two angles in half. So this angle has to be congruent to this angle. This angle has to be congruent to this angle. So we need to find the measure of angle 1, measure of angle 2, 3, and 4. All right, well, we don't need to know this guy, but we do know that he's 50 because he has to be the same as this one. All right, what else do we know? I actually know that angle 3 also has to be 50 because if you recall, we had a theorem several sections ago that said if you had an isosceles triangle where the two sides are congruent, then their base angles also have to be congruent. So if you're looking at this triangle, then the base angles have to be congruent, meaning 3 has to be congruent to 50. So 3 is also 50 degrees. All right, and then because of my angle bisector, I know that 3 is the same as 2, so he also has to be 50. And now if you maybe even turn your shape a little sideways and see this triangle, I know I have my two base angles are both 50. I could find angle 1 by simply taking 180 minus 50 minus 50, which would be 80. And the same thing is true with 4. Again, we have the same triangle situation over there, which would be 180 minus 50 minus 50. Which equals 80. And there you have all of your angle measures. All right, let's try another one. Here, another rhombus cut by a diagonal. I know this diagonal is 30. What do we know about the rhombus? All the sides are congruent. So if this angle is 30, then angle 1 also has to be 30. All right, now I have an isosceles triangle here. And I know the base angles are both 30, so I could find angle 2 by simply taking 180 minus 30, which would be 120. We also know that opposite angles in a rhombus are congruent. If you didn't know that, now you do. Or you could have also realized then that this angle has to be 30 and this angle has to be 30, therefore I have the same triangle here. And I could find my angles there. All right, hopefully this isn't too fast for you. All right, what about this guy? Angle 1 falls right in the middle here. And remember, we had a theorem that said that the diagonals of a rhombus are perpendicular, meaning they form these right angles, meaning that angle 1 has to be 90 degrees. All right. I know that all the sides of a rhombus are congruent. So I know that this angle has to be congruent to that angle. So the measure of angle 2 has to be 45 because they're base angles there. All right. Now there's a lot of ways that we could find angle 3 and 4, but let me draw your attention to this triangle right here, a right triangle, where we have a 90-degree angle here, a 45-degree angle here, and one other unknown there. And of course, we could find the measure of angle 3 in that small triangle because it has to be simply 180 minus 90 minus 45, which is also 45 degrees. And the same thing would be true in this triangle to find the measure of angle 4. This one has to be 45 because of this angle bisector right there, the diagonal, meaning that angle 4 also has to be 45 degrees. All right, not too hard. Then you're going to have a problem type with rectangles, where we learned that rectangles have diagonals that are congruent. So when they give you two values for the diagonals, we know that they have to be set equal to each other in order to solve. So if I wanted to solve for these diagonals, I know that AD is 6x minus 2, and that has to be congruent to this should be CB, which is 3x plus 10. And if I solve, I get 3x equals 12 and x equals 4. Now be careful, maybe they'll have you solve for x, or maybe they'll have you solve for the diagonal. So if you need the diagonal, you need to plug it back in. So you'd have 6 times 4 minus 2, which is 22. And of course, CB also has to be 22. You should be able to plug it in and make it work, but we know that the diagonals are congruent. So once you have one, you can just fill in the other if you need to. All right, one last example. If you have to find the sides of a rhombus, again, the sides are all congruent, just like a square. So all you have to do is set them equal to each other and solve. So 5x would equal 10, x would equal 2. All right, you guys, that's it for this section. So go ahead and finish up your notes, read through the examples, and begin your assignment.